Okay, we shall start the meeting because it's 3 o'clock. Welcome everybody to ioLight webinar on the world first portable microscope. Before I start, I introduce Andrew Monk. Andrew Monk is the co-founder of ioLight Limited with Richard Williams. Richard and Andrew have patented a pocket microscope that shows beautiful microscopic images on the display on a mobile phone or tablet for simple sharing. The images have a resolution of 1 micron, 1,000 of a millimeter, which is comparable with the laboratory microscope. The ioLight microscope holds to fit in a jacket pocket and is simple for use for field scientists from 8 years old on upwards. This is the first time that a portable digital microscope has delivered lab quality images. Our initial markets are education and animal health, but the potential application to human health in developing countries is exciting. The microscope has been to the forests of Alaska and the Amazon and to Kazakhstan steppe to research saiga and tulip. Andrew has a master's degree in physics from Oxford University and always been passionate about developing scientific research into products and services to improve life. He has run startup companies in California and France, as well as UK, and is an enthusiastic musician. Over to you, Andrew.
Thank you, Jimmy, and it's great to meet you all. And thank you for your time this afternoon. We're going to talk a little bit about this little microscope in this pouch, and we'll have a play with it. I'll show you how it works later, but first I will give you some background. I think you can ask questions during the talk. Is that right, Jimmy? Can we ask questions?
Yes, you can ask questions.
Yeah. So don't. I like being interrupted because I'm a really boring speaker. So it's better if you interrupt me, and that's great. Or keep them to the end, whichever you like. And Jimmy, if you can help people if they have questions, if you can just interrupt me and so that we can do them.
Yes, I think you finished the presentation, then we answer Q&A.
Yeah, okay, cool. So let's just put this. So I have a few slides. I hope you can all see that. So I have a few slides which will last about 20 minutes, and then we can have a little play with the microscope so that you can see some things, see how easy it is to use. And then we'll have some time at the end because the most interesting thing will be your questions. So how do you increase the profit of a farm with a microscope? How does that work? Because most of our customers are vets and aquaculture fish farms, and the first question they always ask is how do I increase my profit? So let's have a look at that. Just remembering how to work this. So as well as profit, we have a problem with food in the world. The world population is forecast to reach over 9 billion by 2040. And as well as that, there's a big pressure on the environment that people should stop cutting down trees because of the oxygen they create and the decarbonisation they create. So we need to reduce deforestation. So we have to feed these people, we have to grow more food on less land. So we need higher yields. And that is why there's such a big boost in fish farming in the world, because fish farming means that you can get a very high number of calories, a very high amount of protein from unexploited areas in the ocean. And that applies to every branch of farming. I'm going to have a look at every branch of farming. So how does the microscope help you with profitability? Well, you lose profitability when your animals get sick or when your plants get sick. And while they're sick, two things are happening. Firstly, you're losing productivity. And secondly, the disease is spreading through the stock, and particularly with fish. You've got a lot of fish in a very small space in a fish farm, and the diseases can spread very quickly indeed. There are stories from Norway of diseases spreading in rivers so quickly that they have to put chlorine into the water and kill all the fish because the disease has just spread through all the fish in the river. So it's really very serious. And for most of these diseases, the microscope is the gold standard for diagnosis. There are some other molecular tests, but they're not as reliable, they're not as robust, and they don't give you as much information. So what people do today is they take a sample from the fish or the animal and they send it to the lab. And 2 weeks later, it comes back from the lab and it says you have a problem. But by that time, a lot of stock has died, and maybe your farm has been shut by the government. I don't know about in Singapore, but in the UK, we had a disease 5 years ago in cattle, in cows, called foot and mouth disease, and the government shut nearly all of the farms, and these farmers were not making any money during this time. So if you can treat immediately with no lab, then you can stop the shutdown. It's a bit like lockdown for coronavirus, maybe. So if you can immediately detect and treat, then the lockdown is less. And the losses, your lost profitability is stopped immediately. And you get another benefit with having the microscope on the site, and that is that you can show the farmer, the vet in this picture on this slide is explaining to the farmer the parasite that is inside its animal. And that way you can educate the farmer and train the farmer to give the correct treatment to the animal. And we'll talk a bit more about that in a moment. So here is our microscope, and Jimmy has already introduced it beautifully. It's a pocket microscope. You need a big pocket, but it's a pocket microscope, and it displays images onto oh, my phone, where's my phone? Onto any mobile phone. This is an Android phone, it works on iPhone, it works on iPad, it works on anything. Today I'm going to show you an iPad just because the pictures are a bit bigger, so you can see them more easily. And the pictures you can share, immediately you take a picture, because the phone is connected to the internet, immediately you take a picture, you can send it to an expert in America or in the UK or in Germany or wherever your expert is. You can send it around the world and say, what is this? What am I looking at here? What should I do? So that immediate sharing while you're still on the farm is really important. And it really can go anywhere. Our little microscope, where's it gone? Here it is. Has already been to Antarctica. It's been to the Amazon rainforest. It's been up Mount Everest. And maybe you don't care about those things because that's not where you work. But if it can go to those places, it can also go to fields. It can go to fish pens. And this, many of our customers use this on a boat. And there's a good use case on a boat. If you use a normal microscope on a boat, it falls over and you get really seasick because the boat is doing this and you're looking in the microscope and, you know, it's really not nice. With this, you don't get that problem because you're looking at a screen. And also, a lot of our customers are like this vet here is a mobile vet, and she is working from the back of her truck, and she drives to the farm and she can do tests on all the animals on the farm at the same time. So it's very good for mobile vets, and we have a lot of mobile vets now, well, globally, US and Europe as well. So about my company, as Jimmy said, we founded it in 2014 with myself and Dr. Richard Williams, he's the brains, I'm the good looks. So we have sold over 300 units around the world, and most of our farmers are most of our customers are vets and farmers, agriculture colleges, government agencies. Jimmy and I were talking about government vets in Singapore yesterday. In most of the world, in America, in Europe, in the UK, the government buys is one of our big customers, because they buy this unit because they can take it to farms and they can test their farm products there in the farm without having to take them back to the lab. So that's very important. Aquaculture is a big one. Salmon farms, salmon is a huge industry, but also prawns, and research. So research universities around the world use this. And another one for us at the moment is environmental science. There are many, many research groups around the world working on climate change and looking at the impact of that on farms and on oceans, because climate change, of course, affects all farmers. So beginning with aquaculture, Jimmy, I put this other picture in because this is the bottom one is my picture from England. This is near my house. This is the beautiful River Itchen near Winchester, which is a very famous river for growing trout. They grow very good trout. And this gentleman is looking for the food for the trout in the river, and also for parasites, to see if there are any parasites that will infect the trout. The top picture is a more normal fish farming situation. This is from Norway, which is a huge fish farming area. And these are salmon pens with salmon growing inside them. And the salmon, the threat is this salmon fluke, Gyrodactylus salaris. And in the UK, this is what we call a notifiable disease. If you have this, if you detect it, you have to report it to the government, and the government will come and close that river or close your fish farm, because it is so dangerous. It spreads so quickly that you will lose the whole stock in a few days. And when you've got something that's growing that fast, it's really important to have a very fast diagnosis. Salmon fluke is, some of you will have seen it, it's a very, you can detect it easily, it's easy to identify. So with a farmer, even with a farmer without a vet, you could take a picture of Gyrodactylus on this microscope, send it to your vet, and your vet would say, oh my goodness, you need to destroy that pen, or you need to put some medicine in the water, or something. And because you act fast, you prevent huge losses. And the potential losses from this parasite are really, really big. The other thing Jimmy and I talked about was looking at the feed, what the fish are eating. And this is what Sean is doing here, is he's looking for the natural protozoa that the trout are eating, but it's the same in every fish production environment. You need to look at the fish farm, you need to look at the quantities and qualities of the feed that the fish are eating. The same is with livestock. I know you don't have much livestock in Singapore, but there is livestock in other parts of the world. And there's a big problem with livestock this is cows and sheep and pigs, goats, chickens. There's a big problem in Europe and the USA with livestock, and that is with these parasitic worms, gastrointestinal nematodes. And these are eggs. These ones are actually harmless, but the different species are very dangerous. This is a tapeworm, this one. So we need to detect these. And the reason we need to detect them is in the past, the vets have said to the farmer, you must worm your animals, you must treat your animals every month. And the problem with that is the worms become resistant to the drugs. So you give the drugs to the animal and the worms just say, oh, that's okay, I don't care, I know how to deal with that. The only way to fix that is to only treat the animals that have worms. Don't treat the animals that don't have worms, because otherwise you build up this resistance in the worms while they're on the ground. And so the vet should be looking at which animals have worms and which animals like this one are okay because these are not harmful worms. And so you reduce the amount of drugs you give to the animals. The worms are not resistant to the drugs anymore. You reduce the drugs in the food chain because government health people are always worried about the drugs in the food that we eat. And the best thing for the farmer is if you're buying less drugs, you're also paying your vet less. So it's more profitable. And the great thing about what I'm talking about here is just by helping nature, we actually save money for the vet as well. So the customer is very interested in this. And the same applies to plants. This is a good example for plants. So for years and years and years, for 100 years, we've been using chemicals on the fields and treating the soil with phosphate and nitrates and carbon and just playing a chemistry set in the soil. There's no, on a big farm, there's no life in the soil at all. It's completely dead. But now in Europe and America, excuse me, there is a big move towards what's called regenerative agriculture. So for regenerative agriculture, I don't buy any of those fertilizers. I don't buy anything from Monsanto. And that cuts my costs hugely straight away. And then I use some nature tricks. I grow two crops together. One crop protects the other crop. And I introduce into the soil little guys like this nematode in this picture, and they help me kill the pests in the soil. And I also use fungi in the soil, which keeps the soil healthy and rich. So it's going back to old-fashioned farming like 100 years ago. The productivity of the farm is a little bit lower because, see, without all the chemicals, we produce slightly lower quality crops. But we haven't got the big bill for fertilizer. So the profitability of the farm is higher. And also the price of the crops that we can sell them for is higher because people pay more where there's not chemicals used, where they know there's been good farming. So this is a really interesting movement, and we see this all the way around the world. To do this, the farmer has to watch the soil very, very carefully. And to do that, he needs to have a microscope. And this is with Singapore being in the ocean and most of Southeast Asia being very close to the sea. Algal blooms are a real problem. This is a horrible impact of climate change. You see this algae on the sea or on the lake or on the river, and it's a green algae, but some of these algae contain cyanobacteria, and they kill fish, dogs, even humans have died from poisoning from cyanobacteria. The problem is you can't look at this and say this is a dangerous algae or this is a safe algae, because they look exactly the same until you put them under the microscope. So we have a partnership with the State University in New York, Professor Greg Boyer, who runs an algae lab, and the people that live on the lakes in New York State can take their samples to Professor Boyer, and he will analyze them in the lab and tell them whether the lake is safe to go in, to take their boats in or take their dogs in or to swim in. And obviously you don't want to swim in this water. This is clearly dangerous. But how do you know? How do you know that? So if you send your sample to the lab at the State University in New York, it might take a week or 2 weeks to analyze the sample and to report back. If you send Professor Boyer an image from your ioLight microscope, he can tell you whether it's okay or not in 1 hour. And you can get your boat out and you can go on the lake. It's not a whole day or a whole week. So Professor Boyer is lending these microscopes to the people who live near the lakes, so he can track these isocyanate algae. They're really nasty, and we have them in the UK as well. Not so bad, but also on the west coast of Europe, in France and Spain. that are where there's a big market for shellfish, for oysters, for lobsters, and this kind of algae can kill shellfish, and also, worse than that, make the shellfish poisonous for the people that eat it. And so they're very careful about protecting the shellfish. So this is Nellie and Molly, they're two cows, and they have approved of the ioLight microscope, which is used on their farm. So I hope you've understood this little talk, that if you can diagnose a disease on the farm, whether it's aquaculture or animal farming or vegetable crop farming, if you can diagnose disease on the farm very quickly and treat it, you will increase the profit and help the environment, because the productivity will go up. And for most tests, when you send them to lab, they use a microscope. The microscope is gold standard for most pathogens. And with this microscope, you have no expensive lab delays. So you can get an answer immediately, and that means the vet only has to visit the expert only has to visit the site once. With the lab, you have to go once, take the sample, and then go back again a week later and make the treatment. So you get an immediate increase in farm productivity. And this works across all sectors, across fish and livestock and crops. So that's the end of my talk. I hope that was interesting. Right, so we stop sharing. Good. Any questions straight away?
Any questions? We have only 2 participants. Any questions? Kim, Zola?
Okay, well, what we can do is, Jimmy, shall we have a look at the microscope?
Yeah, okay, we have some demonstration on the microscope.
Yeah, let me close this screen. Let's get rid of that so we can see what's going on. Okay, cool. Right, so what I'm going to do, I'll just try to get. Oh, there we go. Right. So what I'm going to do is I'm just going to move my camera down onto my desk so that we can see here. This is the microscope, and it really is very small and it's flat. That's the clever thing about this microscope. The other thing is there are a lot of portable microscopes around, but they connect by USB, and you need a stage, and you need an illuminator, and you need a computer, and you need a lot of stuff. For this microscope, all you need is a microscope and a mobile phone or an iPad. That's all. So we can open the microscope, and microscope works. It has to have a stage. Any microscope that doesn't have a stage can never be lab quality because it doesn't hold the sample still enough. Okay, so Keen, there's a question about, that's a good question. Can I answer that in a minute about the coronavirus? The answer is yes, but I'll come back to that in a minute. This microscope can unfold like this. So we can see a slide on there, and I can put the slide, just normal microscope, or even a sample without a microscope slide. I put on the stage like that, and I can focus the microscope like this. So now I have a normal iPad, and here is my secret password. So we just open the Wi-Fi settings. Can you see? No. Just open the Wi-Fi settings, and you see, you can't see this, but down here are all my Wi-Fi networks in the office. And one of those networks is called ioLight 160216. and that is the serial number on the bottom of the microscope, 160216. So we know that I'm connecting to this microscope, and you don't need Wi-Fi because this microscope makes its own Wi-Fi network. So that's how we can use it on Mount Everest. So now I'm going to connect to the microscope, and now I can open the ioLight app. Oops. Connecting, just trying to put it somewhere where you can see a little bit better. There we go, you can see a little bit better there. So now I can, just with my hand, move the slide, and I can focus just with my hand, and then you can see coming into focus there. Now, this is quite a nice picture. You can't, obviously the picture you're seeing on the screen isn't quite so good, but now I can do the detail, the fine focus on the screen of the microscope. So you don't have to focus it exactly on the microscope, and then you can move the sample around like this. This is a section from a fish, and you aquaculture experts will tell me what I'm looking at here, but I'm a physicist, so I don't know. Usually you can identify the gills quite nicely. Let's see if I can find one. There we go. Maybe those are gills. I'm sorry if I'm wrong, but it's a good job. I'm a microscope expert and you're the fish experts. Anyway, you can find parts of the slide very easily, and all you need is the tablet and the microscope. There's no cable, there's a wireless connection, and we can also capture an image. I'll just make sure that this image is properly focused. There we go. And I'm going to take a picture of this. And this captures now a full 5 megapixel resolution image. It's a really nice picture. I will send this picture to Jimmy, who will send it to you after this meeting, so we can use it as part of the meeting. So that's it. Now the question that Keen asked was a lovely question, and everybody asked this question. Everybody asks this question at the moment, and that is, can we use it to detect coronavirus? And the answer is, we'd like to, yes. So we are currently working, we have a version of this, which you'll see on our website, is a fluorescence microscope. And it's the world's smallest, least expensive fluorescence microscope. And a lot of the tests for coronavirus use fluorescence to detect the virus. There's a Merck Millipore antigen test that we're using that detects coronavirus. So we're working with Oxford University and the Kenyan Medical Research Institute to develop a process that would detect coronavirus in remote areas. So this is a rapid transit, high throughput, high sensitivity test that you can put in the back of a truck, and you can drive it into the middle of the jungle in Kenya, and you can make the tests on remote communities. So that's the project we're working on. And we would love, if you know people who are developing coronavirus tests, we'd love to work with them as to allow them to make their tests mobile. So that's really important. So good question. And there's another question from Keen that's, the optics is plastic. Yep, that's right. How stable is it at times 200? Times 200 is fine. This can go up to much more than, okay, let me show you this. Let's find the sample again. Oh, you can't see, can you? So we say times 200, but digital microscopes don't really have magnification. Because if you think, there's an eyeball, look. If you think what times 200 means, Keen, it means that the image I'm seeing is 200 times as big as the image on the slide. But I'm not seeing an image, the image is on the iPad. So for a digital microscope, magnification depends on the size of the screen. So this is a 1mm microscope. It says 1 on there, so 1mm microscope. That means that this distance is 1mm. The iPad is nearly 200mm wide, the screen. But this image is times 200 on this screen. But if I make it, whoops, if I make it bigger, this is now times 400. And if I put it on the side of a big building, it's times 5,000, no problem. But the problem is, of course, that it's not the magnification that counts, it's the resolution. It's like any digital image. The bigger you make it, the more grainy and lower resolution it becomes. And so what we see is that we can take objects that are 1 micron and we can still see them clearly. 2 objects that are 1 micron across, separated by 1 micron, we can see. We have that resolution of 1 micron. So it's the resolution that's important. Times 200 is fine. The plastic is not the problem. The lenses in mobile phones are plastics. In fact, these are mobile phone lenses, and they're really, really nice quality lenses. The quality is that the problem, the challenge is the whole optical system working together. And that's why we say that the resolution is 1 micron. We don't use times 200. We sometimes say times 400. Most people would say it's in between, but it's an opinion. So I hope that helps answer that question.
Can you show us some of the images for aquaculture, Andrew?
Yeah, sure. Yeah, let's do that. So Jimmy asked me to pick out some images. Let me put this back on me. And then, so when you asked me for a copepod, so this was taken. Richard did this one, so I'm not sure where this comes from. Yeah, I think this comes from the Scottish Association for Marine Science in Scotland. So I think that's a copepod. Does that look right?
Yep, it's good. Looks good.
Quite nice quality, yeah.
Yep, very nice.
So and then what else can we do? So this is a video. I hope the video is working over the line. Is that okay?
Yes, yes, yes. It's
so
algae.
Yeah. Yeah, it's Alexandria minutum. Why did that suddenly change? Oh, right. So let me try and play that again. Sorry, this is my computer being silly. So this is the algae that causes the shellfish poisoning I was talking about, and that was done by a customer who is tracking the shellfish poisoning in the west of the UK. So that's really important to them. Right, this one. I'm going to put that, see if I can put that on a loop. How do I do that? Right, let's try that. This one I love. This is so cute. Right, who knows what that is?
It's a Daphnia.
Yeah, it's a Daphnia. And the thing I like about this is you can see, if you look here, you can see its heart beating.
Yep.
It's a really nice image. So I got that from the Royal Agricultural University in the west of England. So that's quite a nice one. Let's stop that. Sorry, I should have put these in a presentation. What else have we got? So there's a let's put this one on a loop. Oh yeah, it is on a loop. Right. Screen share. Okay, so this is algae, and this is on a loop. So I think these are Volvox, and there are some algae here, and so this just shows you the sort of breadth that you can see. Some of this is out of focus, but that's because it's a very thick slide and the focus changes as you go through. We can fix that. We can do Z stacking, or you can move the lens through it and do a video. But that's quite a nice one. Quite like that one. What else have we got? Okay, now here's one that we've looked at already, but let's just have a closer look at it. So, can you see that?
Yes.
There should be a nematode, yeah?
Yeah, nematodes.
Yeah, so this is a soil nematode, and this is what the farmers are looking for that are doing regenerative farming. This nematode's quite big. It's about 0.5 millimeter long. It's only about 50 microns wide, so it's quite small. Actually, less than 50 microns, maybe 30 microns wide. But these are the life you look for in a soil if you're a farmer. If you've got these in your soil, then your soil is healthy. But they also like to identify them because some of them are really dangerous. One of my customers is an expert on soil nematodes, and if you look at the mouth parts, I don't know which end is the mouth, but maybe this end, you can tell the difference between the good ones and the bad ones. And I don't know if you follow English football, but there's a football club called Arsenal that has a football ground in London, and they had the bad nematodes on their pitch 6 weeks before the beginning of the football season, and they just ate the whole pitch. It went brown. And of course, there's big money, and they couldn't play football on the mud. So he was called in to with his microscope to look for these bad nematodes, which they treated and then replanted the grass, and they were ready for their first match of the season. So that was ioLight saving the season for Arsenal Football Club. Right, what else have we got? Oh, yeah, these are lovely. So there we go. So my daughter has done some exhibitions with us, and she was doing one when she first went to school. She was 11, and the teacher said, so what's your favorite animal? And they went around the class and they said dog, cat, rabbit, and my daughter said my favorite animal is a tardigrade. And the teacher didn't know what that was. So these are 2 tardigrades. There's a very nice video of tardigrades, and you can see the gut
very nice,
and
very nice.
Everything. Yeah. Good. So I hope that's been useful. Jimmy, are there any more questions, do you think?
Looks like no more questions. Keen, have you any more questions? Any more questions, Zola? Victor? Yen now from Burma. Victor, any questions? There's a question.
There's a problem. There's a question from Keen here on the Q&A about chromatic aberration. Wow, you've done some optics, Keen.
Yeah, he's an engineer.
Yeah, so chromatic aberration is always a problem in lens systems. Just for those of you who don't know what it is, so lens bends light, and as you know, white light is made of lots of different colors, hundreds of different colors. Each color is bent differently when it goes into the glass or the plastic of the lens. because of something called Snell's law. And each color is bent differently. So if you just use a cheap lens, if you get the lenses you get with, you know, for Christmas or something like that, the lens that kids have, you'll see that around the edge there's different colors, and because they're all bent differently. So one of the things that we do in optical design is our core skill. Richard is absolutely expert in optical design. He's designed the lens system in here, and of course he designs it to address chromatic aberration. So Keen, if you look at the pictures we send you and the pictures I've shown you today, I hope you can see no chromatic aberration. There is a little tiny bit sometimes, but it's very hard to see, and it's not something our customers ever complain about. We've never had a complaint about chromatic aberration, but have a look at the images I send and tell me if you can see any. Okay, so we nearly finished. Jimmy, do you think?
Yes, we have finished, unless there are any more questions from Kin or the rest of the attendees. Looks like.
Well, can I make a special offer?
Okay.
So we have, if you look at our website, to go with the folding microscope, we have a plastic case that and it's good for people in aquaculture, because if you take this on the boat, you know, things get knocked about on boats and sometimes they end up in a little bit of water. That's fine for our microscope, not a problem. But to protect it, we have a case. And if any of you guys buy a microscope from us in October, I will give you a free case to go with this. How about that?
Okay, okay. A soft case, then?
No, hard case.
Oh, it's a
proper
hard case.
Yeah. So the soft case is free with every microscope comes with one of these. But the hard case is more robust and it's bigger, so it has room for the power supply. I haven't got one here to show you, but if you look at our website, you'll see it. It has a power supply, it has a few slides in it so that you can get started, and it will really protect the microscope. You know, you can drop it and it's fine. It's pretty tough anyway, but the case just makes it double tough.
Okay, Kin has two questions. And put a scale on the image so that we can tell the size.
Oh right, the size of the size of the microscope on the image. Yeah, so the image, there is already a scale. That's a good question, actually. Let me just show you how you do that. So if you go back to my fish image, that's a very good question, Jimmy. Sorry, I should have covered that in the talk. There is something. And just do find focus on the screen. Now, let's see if we can find something. I found an eye before. I don't know where that is. There are those, some more of those feather structures. So how do I know how big this is? What magnification this is? Well, this is a 1 millimeter microscope. You can see there's a 1 on the microscope. We also do a 2 millimeter microscope. What that means is that this distance, the width of the screen, is 1 millimeter. So this is half a millimeter. So that is 0.5 of a millimeter long and 0.2 of a millimeter across. So you can easily tell because the size of the image is always the number on the side of the microscope. So this is always 1 millimeter. And if it helps, you can add the settings button I've just touched, and you can put a grid. Maybe you can't see that, but can you see the squares? There's a grid, square grid on there, So I can see that this structure here is 1, 2, 3, 4 squares long, so that's actually 0.4 of a millimeter. So the scale is free. All of our images are the same size. Okay. So you can calculate the scale from that, Jimmy, if you want.
Now, if you can see the grid, you can calculate.
Yeah, exactly. So there are 10 squares, it's 1 millimeter, so each square is 0.1 of a millimeter or 100 microns. So that really helps. And if you want to be accurate, you can just measure with a ruler, and it's very easy to just divide by the width of the screen, and you can very easily calculate any measurement on the screen. So that's one of the big advantages. Good advantage if you use it for teaching. Teaching is very interesting because it's very easy for particularly kids to imagine how big things are.
Kin was asking what's the price. So maybe you can show the website, and through your website, and you can actually show the price on the screen.
I can do, probably.
Maybe easier.
Right, let's find the website. Should have the website up all the time, shouldn't I? Right, so just go back and share the screen. So here is our website, and you can see the markets that we talked about. So teaching, I mentioned teaching and outreach is another market. And this is a nice image showing how it can be used far away from the lab. This guy is our friend Munib Kanyari, and he's working in Kazakhstan. So that's really, really great. But from the products, so the basic product, the 1 millimeter microscope, is 840 UK pounds, which is about 1100 US dollars. Sorry, I'm a bit out of touch with the Singapore dollar. I don't know how much that is in Sing dollars, but it's about 1200 US dollars. And then there are other products. So we do the same microscope, but with an XY stage. Some microscopists want to have that XY feature so that they can be really accurate with positioning the sample. You saw me doing it by hand here, which is quite easy. But if you're scanning and you want to find some specific detail and you want to be able to come back to it, you need an XY stage. So we have patented an XY stage that goes on this unit, and the stage of the microscope is now made from metal, and it has 2 grooves, and the stage moves backwards and forwards, and then the slide moves left and right inside the stage. And so that one is a little bit more expensive. That's about, well, what's that, about 1600 US dollars, I think. So there's a choice, and there's lots of other products as well that you can see. But that's roughly the price example. There'd be some shipping to Singapore as well, but Jimmy and I can sort that out for you.
Okay, one more question from Keith. Does it require any preventive maintenance on your microscope?
Yeah, these are great questions, Keen. Well done. Yes. So what microscope people do is they take a lab wipe, like this is actually a coronavirus wipe, but lab wipes are the same, and they get the lens and they go, "Urgh, please don't do that, okay? It's a plastic lens. If you clean it, you will scratch it. Not a problem. We can replace the lens for you, and it's not very expensive. But please don't clean the lens." So the best way to clean it is to get the lab wipe, or even a coronavirus wipe, and just wipe the whole surface like this. Okay, so that just wipes all the bits of fish and things off it, and it's much easier to clean than a normal microscope. If you have to clean the lens because it's really dirty and you can't see anymore, then you use the corner of the tissue like this, and you just touch the lens, stroke it like that. But I would only do that if you really are having problems seeing. The lens doesn't get particularly dirty, and even if there is a little bit of dirt or a scratch on it, because of the way the optics works, it doesn't interfere with the thing. I've had this microscope for 3 years, and it's still the original lens, so it's fine. So it's not really a problem. The only other thing, the most common problem you'll find with customers is they say, "Oh, it's stopped working," and so just ask if this light is flashing or on. Flashing means it's standby, on means it's actively sending a picture. The most common thing is that people forget to charge them. It's like my daughter and her phone. My phone stopped working. "Oh, have you charged it up?" "Oh no, I forgot to do that." So, and sometimes if people are carrying it, this button, the power button, can get pressed, and it can get turned on accidentally, and then the battery goes flat, even if you're not using it. But those are the only things to watch out for. It's very strong. I drop this fairly often, usually in airports when I was traveling, and it's never a real problem.
Is it weatherproof, according to Keith? He's asking the question.
So it's like a mobile phone. So is a mobile phone weatherproof? Well, officially it's not. You wouldn't say a mobile phone is IP68 or anything like that. But you know that if you leave your mobile phone in the rain, it will be fine, as long as you dry it off quickly. This is the same. The edge of the stage here is all sealed. So if you're working on a wet subject, it's not the liquid's not going to get inside the microscope. If you drop it in a bucket of water, if you dry it out quickly, it should be okay, like a mobile phone. But I wouldn't. That's not recommended. I wouldn't do that.
How weatherproof? What? Kin, you can talk, right? Kin, you're already on voice. Cannot see you.
Oh yes, can you hear me now?
Yeah, of course.
Yeah, we can hear you.
Hello, Andrew.
Hi, Keen. Nice to talk. Nice to hear you.
Thank
you for all your fantastic questions.
Thank you for your answers. Very clear.
Good.
And you speak very clearly, so I understand exactly what you're saying. Thank you.
Good. Jimmy says I speak loudly. Is that the same thing?
No, loudly and not being able to be legible.
Yeah.
Yeah.
Kin graduated from UK, so he speaks perfect English.
Well, I had I'll tell you a little story. I was once speaking at a sales conference with people from all around the world, and it was led by an American company. I was working for the American company at the time, and we had the same conversation about whether people could understand my voice. And the American host looked at me and he said, "We can't understand you, Andrew. Do you know why? Because you are the only person here that speaks good English. Everybody else speaks bad English, and you can't speak bad English, so we don't understand you." So that was quite funny.
And Andrew,
Yeah.
where are you based? Where's your lab or your office?
We're based in the UK. Do you know the UK very well?
Fair enough. Well enough. Yes. Go
Yeah.
ahead.
So we're about an hour southwest of London. So we're near the city of Winchester and the port of Southampton. So Southampton is on the south coast, and the manufacturing is actually in Southampton.
Ah, yes. I know where that is. Yes. So we were in Southampton only last April. So so no, not the year. Last year April. So yeah. I can imagine where your place is. Yes. What is it called again? The town?
Southampton.
Oh, you are near Southampton.
Yeah.
Or you are in Southampton.
In Southampton. So the
I
manufacturing.
see.
So my office where I am now is just north of Southampton near Winchester. And the manufacturing where Richard is actually right in the middle of Southampton City.
Understand, yes. So do you commute much to London to promote your product?
I used to do, yeah, before coronavirus, but people don't go into London now because it's there's too many people. The tube is just full of people, and I love London. London's a wonderful city, but I haven't been there for 6 months, which is very strange for me. Usually I go once a week.
Mm. So you usually drive from Southampton to London?
No, because where I live, there's a direct train. Driving in London is not a good idea. It's just too busy, too much pollution, and they have I think you have this in Singapore as well. You have the charge for the congestion in the middle of the city, in the central business district. So the train from my town takes 1 hour to get into the centre of London, and I can work on the train. It's very, very convenient, very cheap. So yeah, it's good. And we used to go in there a lot to present the product and also to meet with our investors and finance meetings.
So when would we get a sample for demonstration in Singapore?
It's a good question.
We can ship one tomorrow. If you place an order, that's fine.
Mm. Should you send a sample to Jimmy so that he can demonstrate it to all the various establishments?
So I've talked to Jimmy about this, and we've arranged a deal on a demo unit, and I'm sure Jimmy is thinking very hard. Jimmy, I'll just remind you what that deal is in an email.
Yeah. Okay.
And I'm happy to include the free case in that demo deal as well. So you get 2 discounts in one order.
Very nice of you. Okay, any more questions? If not, we have to close the meeting. Kin, any more?
No more. Andrew, we hope to see you in Singapore when travel, the restriction.
Well, I was telling Jimmy, I love Singapore. I love the food. It's some of my favorite food in the world, Singaporean food, because it's so varied. And my wife was actually born in Singapore. She was born in Changi. Yeah, I'd be very happy. Maybe I'll bring my wife too.
Sure, by all means, you're welcome.
Thank you.
Maybe next June when the WAS conference is on.
Yes. Yeah, that would be great. That's a really good idea.
But this is a big seminar, that one. It's international.
Yeah.
Okay. Bye, Andrew.
All right. Thank you very much, everybody, and thank you for listening. I really appreciate it.
Thanks, Kate, Zola, Victor. Yeah. Thank you for attending.
And thank you to Jimmy for organising as well. It's great.
Yes, thank you. Thank you, Andrew. Thank you for your time.
Bye.
Bye, we leave now.